And it's been a little while since I've been at one of these because I think I falsely assumed that you've all seen them before. And I know that every time I do come to one of these, I'm always amazed at, even if it's a demo that I've seen, how creative and different someone's use for it is and someone's explanation is. But I'm actually going to kind of go the other direction and come up with something that probably is a little over the top and is a little too complex for most of my classes, but only because it was requested this year. So I love the milk of magnesia demo, and I'm sure you have probably seen this one, but where you just make the milk of magnesia color will appear and then disappear but reappear. I think someone messed with my milk of magnesia. I need to shake a little more. It's not supposed to be doing that. That's a little better. Not sure I really trust this brand. My other document is dead. But anyway, the milk of magnesia, I've done so many times, and what I've done it on parent night as for our open house. I do it for my sophomore chemistry students, and then I do it again when we get into AP chemistry and of course start talking about solubility. And I always love bringing this idea that, hey, this is a demo that maybe you didn't appreciate at a certain level before. You just saw it as, hey, cool, that's a color change that's taking place. That's telling us some reaction is happening. And now you have the ability, the sophistication, to try to explain in terms of some other chemical principles like solubility equilibrium. But I have a really unique class this year. And if you haven't seen this before, we'll just show you acidify it, but as long as there's still milk of magnesia, the color should return. I have a unique class this year, though, that one of them posed the question, what do you do if, is there another way to somehow make the hydroxide go away? So we took this one, put it aside, I made a fresh one, and I stood back and I said, like what? Tell me what to do. And this is the first time that I had done this with a group, but it was like their dream of, hey, we get to just tell you what to mix and you'll mix it. I'm like, well, not exactly. I'm going to have certain parameters. I'm going to have a few certain rules. I'll let you tell me why you think it's going to work, and if you provide a good enough justification for what's going to happen, then yeah, we'll go ahead and give it a try. So they just said, okay, well, what could get rid of hydroxide besides an acid? And somebody brought up this idea of selective precipitation. What if we found something that was going to be less soluble than magnesium hydroxide? So, like, okay, if you can tell me what, and kind of prove with the numbers, and then we'll go ahead and give it a try. And they, of course, picked lead. Thanks for that. But I'm like, well, we'll give this a shot. So we'll pour a little lead in there. All right, and definitely something is happening. It definitely did get less basic than it was before. Now, I'm not entirely convinced that the formation of lead hydroxide is the only thing that's happening. I mean, you could argue and say that lead hydroxide is removing hydroxide. You could also argue and say that if I added an excess of lead, that the lead ion is serving as a Lewis acid, much like iron or aluminum would. But we went with this. We let it sit for a while. We added a little bit more, and we got it to a point where we said, okay, I've definitely made it less basic than it was before because I no longer have that really deep purple color. The same one that's obviously returned in the demo that you've probably all seen before, but we repeat until it does remain clear and therefore can't go back and revert to something basic. So then the problem is, well, what do we do to get the lead out? And like, we need to find something that will be even less soluble than lead hydroxide that can maybe take my lead out. And maybe what it could do is restore some of that basicity. So a kid suggested, why don't you add sulfide? We had a bottle set lab where sulfide was one of the mystery ingredients that seems to make a lot of black precipitates, a couple of yellow precipitates. We'll give it a shot. So I had some sulfide flakes, double bagged, so I didn't have to smell them in my car. I did have my bottle of Universal Indicator cracked and break open on my drive over here. So Paul was kind enough to fetch some for me before we did this. Probably tells me I should change my driving habits a little bit. But I have some sulfide flakes, and we sprinkle a few of those in there. And sure enough, we get like a really dark black precipitate that we could say is lead sulfide. Maybe we see a tinge of the violet returning. Maybe that's because we freed up the hydroxide. Maybe that's also because you have some sulfide also acting as a base. So we don't have all the answers for them on this one. I certainly didn't. But it created good discussion points. But also maybe we have the problem of I have added so much of the Universal Indicator that I've made the color so dark and intense, and I've added so much lead in there that I just can't see. We shut off the stir bar for a little bit to see if there's anything that settles. If it settles, maybe we can see that there's going to be, as the black settles, we'll be able to see a little bit more of that purple restored. And we'll take our time doing that. But the question is then, well, I don't want to have a black precipitate here. What do we do? Is lead sulfide where we end? Maybe we had just done like the silver one-pot reaction, and it ends with silver sulfide, and that's the big finale where, sorry, you just made something that's very insoluble. Game over. You can't really go back and undo it. So I said, well, maybe we could play around this a little bit. And maybe we can try to oxidize our sulfide to a sulfate. So we throw a little hydrogen peroxide in there. So it's actually kind of fun for me, and I was actually really pleased with that the suggestions were coming from various spots in the ring. Don't go over, don't do it. You're going to do it. You're going to do it. Take that. No, one more. Okay. We actually have nitrile gloves in our building now, because we have a student with such a severe latex allergy. They can't even do any latex balloons for homecoming decorations. Even our emergency kits that all have latex gloves, we have to go in and pull them out and replace them with nitrile ones. Rubber bands for Thailand, bought non-latex ones. Anyway, the color definitely changed again. Lead sulfate is white, so it doesn't give this pitch black beaker that I had before, and it's not a dark violet anymore, it's a little more acidic. Now you can, again, say that maybe that's because I'm taking out some of the sulfide, and the sulfide was a base. It could also be because there is a Ka value of hydrogen peroxide. It is a weak acid. There's so many different directions that this can go, and we didn't really have the ability to be able to know with certainty. And so then finally it goes, well, I really like the purple. Could you make it go back to purple? And it was getting late in the period, so I just threw in a bunch of solid sodium hydroxide, made it purple. I just threw in like a few pellets. And actually that's where it really started to bubble. So the last time I did this, it didn't even bubble with the peroxide until I added a little of the NaOH, and I thought that was really cool. Because the bubbles were so thick and viscous that I was able to just take a glowing splint, and every time I popped a bubble, poof, the splint would be lit. I didn't imagine that would be necessarily something we could do here without knowing what the ventilation was. But it was just kind of cool that I got to tell the kids today. I'm like, by the way, that demo that you sort of made up, I'm going to go ahead and do it and see if it's useful to anyone else. I don't think I could really do that one every year. I just think I had a unique mix of kids, and some of them were kind of ready for the next thing, and it was cool to use it as a bit of an assessment to see what did they know and could they make a prediction. And you mentioned that Poe model. Where's Heidi? But that Poe model, that is actually something that it is really cool, and I've heard before. It is I don't always incorporated into AP Chem or an advanced class that I kind of forget how powerful of a technique that is. But it just gave everyone kind of a chance to participate and think of it, even if they weren't the one who thought of the idea and said, hey, do that. You would be able to say, okay, we don't want you to make a prediction, it was your idea. I want someone else to maybe make a prediction or check in with your partner on what you think is going to happen before